Hi folks! So this question that we're going to tackle today is a common kind of question on the long answer portion of the CST exam. I kind of call it the build it triangles question because you have triangles that are stuck to other triangles, and often the thing you're looking for is sandwiched in the middle. And as you can see here, the thing that we're looking for is angle L to Q to N. We're given some information about the triangles stuck to that central triangle, and we're going to have to use those values that we can solve for in those other two triangles in order to get our unknown angle. Now, I always ask students to sort of inspect what they might need as we go from the outside in, that is to work with the outer triangles in order to solve the middle one. And I notice it's going to be quite helpful to find out this side length here from N to Q, and also this hypotenuse here from L to Q. So I'm going to start with the triangle L to R to Q, triangle L, R, Q, and see what we can do to solve for this value here, the hypotenuse, which I'm just going to call X to help us solve for our unknown side. Now I also notice in the question they tell us that the measure of R to Q and Q to P are both 9.5 centimeters, and you can see down here there's tick marks, and those tick marks indicate that they're identical, and they give us a value here. So I'm going to put 9.5 for both of us just so that it's visual. Great. So what we end up having here is our triangle LRQ has an unknown side opposite angle R. Also, we need to find out some more information before we can deal with that. So if we use sine law, we can see that we have some opposite things going on. We have 50 centimeters is opposite the 110 degrees. And we have a 9.5 here is opposite, and we go all the way over, it's opposite this unknown angle here. So we can set up sine law using the equation above, and that rule will look like this. 9.5, which is a side, over its unknown angle, and I'll call it angle L, equals another known side, 50, over a known angle, sine of 110 degrees. Now when we do sine law, we always cross multiply the two things we have, like two places where there are numbers, and kind of divide by the lonely one here, which is the 50. So I'm going to do that now. 9.5 times sine of 110, and I'm going to divide by 50, and I find out that sine of angle L, and it should equal a decimal, and it does, 0.17854 is the sine of our angle. Now that's not our angle. When you do sine law, you have to make sure that when you get this decimal, you do the inverse sine of that decimal. I just leave it on the screen of my computer in order to get the unknown angle. When I do that, I get that this angle is 10.28 degrees, which looks about right because it's awfully skinny up there. Now, why would we want this angle here? It's not the one we're looking for. But what it does is it helps us get the angle we do want, which is R, and it's opposite the side we want, and we can subtract from 180 to find out angle R. So I'm going to do that now. 180 minus the known angle above, and I'm going to minus off the 110 as well, and that'll tell us angle R. And we get an angle of 59.72 degrees for our remaining angle. Now we can do sine law one more time to find out side X. And so in this case we're going to say, well, we don't know side X, but now we know that this angle down here in this spot here is 59.72 degrees. So I'm going to put that in here, sine of 59.72 degrees. And I'll use the two known values that were given in the question, 50 over sine of 110, and then apply the same procedure. And that procedure is to cross the two things we have and divide by the lonely one. So sine of that angle times 50, and then divided by sine of 110. And when we're solving for a side, we don't have to worry. Our final answer is our answer. And in this case, it's 45.95 centimeters. So that's here. So now we have the hypotenuse. Now let's look at the bottom triangle here. Triangle N to Q to P. Now I want that side Q to N. So some teachers have taught about SOHCAHTOA and other teachers have not taught SOHCAHTOA. So you can solve, if you've never heard about it and you don't know what I'm saying, let's just use sine law for this as well. What we do know is that we can subtract from 180 to get this small angle up here. And so if I do that and say, well, I've got 180 minus the 90-degree angle minus 75 degrees. 180 minus 90 minus 75. The tiny angle that's opposite the 9.5 is 15 degrees. So that's here. And it lets us do sine law in order to find out our unknown angle, or unknown side rather, right here from N to Q. And I'll call it Y because I like a single letter. So let's do our sine law accordingly. I have side Y over sine of 75 degrees, because those are opposites. Okay, you can see they're opposites right here. And the 9.5 over sine of 15 degrees. So I'm going to do this here, and I've got, again, cross multiply the two things you have, so 9.5 times sine of 75. And then divide that by sine of 15 degrees. Oh, I just want to make sure I've done that right. Sine of 75 times 9.5. I'm going to divide by sine of 15. And I get 35.45 for that length. Centimeters. Now again, we can do a final sine law to find out the angle that's a question mark. Now, in order to do that, we're going to have this side length over here, L to N. I notice this is a right angled triangle, so let's use Pythagorean theorem to solve that first. So Pythagorean theorem tells us that c squared equals a squared plus b squared. And we have the hypotenuse. We have one of the sides. And we're missing that final side. So side L to N would be like B. I'm just going to do that now. So 45.95 squared minus 35.45 squared gives us 854.7. And then don't forget to take the square root of that answer. And we find out the side up there is 29.24. So that's up here. Okay, so let's do our final sine law to get our final answer. I'm going to take that 29.24 over sine of question mark, because that's what we're looking for, equals two known sides, and I'll use the 90 degrees that's given. It's all right, you can do that in sine law. And I notice that sine of 90, that 90 degrees is opposite the 45.95. So again, I'm going to cross multiply the two things I have and divide by the lonely one. And I find out that sine of question mark equals the decimal 0.636. And I just leave this on my calculator screen. And then we're going to do our final step here, which is that sine negative 1 of that decimal gives us an angle. And that angle is 39.51. So that's helpful. Now, it says to the nearest degree, so we're going to round up to 40 degrees. Because it's 39.51, so you always round up when the decimal is the highest. All right, folks, that's how you solve a putting it all together triangle-style question using largely sine law, a little bit of Pythagorean theorem, and if you did learn SOHCAHTOA, you could have used SOHCAHTOA to solve the final triangle because it's a right-angled triangle. And I invite you to do that if your teacher is someone who is using that in CST mathematics.